Hello, and welcome back to Physics with Joe. Um, that's what we're going to go ahead and call it. We got a request to do Quiz 5 E through H, so we're going to go ahead and jump in that. You should have been able to get this information from the front page. Um, Keep in mind that I had a pulling force. Oops, sorry. So if you had a pushing force, yours is going to be a little bit different, but the concepts behind it really carry on both. So just keep that in mind that these answers actually might be different than yours, but this is a pulling force. So you should be able to find out, P in the y direction is this, P in the x direction. Force friction, the force normal, the mg. You should be able to figure out P sine cosine equals this. If you had trouble with this, Gabe is offering tutoring services, I think, and you might want to contact him because this you're definitely going to need to know that. So the first question, pretty simple. The force you are applying is, what's because the back page is talking about kinetic friction, this guy, versus the front page is talking about static. So it's pretty much saying what is stronger, is F of n u k or F of n u static. So which force is going to be stronger? Well, we know, I mean, it's just the law of physics here, that the static is always going to be stronger. So if we have a force that is equal to this kinetic friction, we know it's going to be less. So we just know that. So this is definitely going to be less than the static force. A big thing to remember here is on the quiz, it talked about how we're moving at a constant velocity. So if we're moving at a constant velocity, we know that the force of friction is going to be equal to the force push or pull, whatever, either way. But they're going to be equal to each other because when forces are equal, that's when you get your constant velocity. If one was bigger, we would be accelerating in one direction. Now, friction obviously would never be bigger. So E is less than. Now, moving on to F. Okay, so write an expression for the magnitude of the friction force acting on the fridge and also give its direction. Well, we already figured out this very handy thing that they're going to be equal to each other. So we know that F push, really, which we don't even, we really don't even need. We just know that this is going to be equal to F of n times the coefficient of kinetic friction. That's, the formula for friction. Well, okay, F of n. Well, hold on. We got to remember here, F of n is here, but we also have another upward force, this Py, which is also equal to P sine. And so our F of n is not just, we can't just call it F of n, because it's not the opposite of mg, because we have another upward force here. Now we know that this block is not moving up at all. It's staying on the ground. There is the forces in the y direction cancel each other out. So this block is not accelerating upward or downward, it's staying constant, staying right where it is on the ground. So I can easily tell that F of n is going to be equal to mg minus p sine theta. I hope that's not off the screen. Now how could I tell that? Well, it's quite simple because mg is the only force going down, so I know that mg is going to equal, well, what are the two forces going up? F of n and py. So I know that that equals F of n plus py. So you just move some stuff around here and you're going to get this formula, which is really what you want in the end. Now, I need to plug that into this guy. So really, for E, all I'm going to have then is mg minus p sine theta, put that in parentheses there, over uk. That's going to be your formula for the force, because remember, I know they're equal. So this is really equal to F push, but it doesn't. That's the magnitude of the friction force. I don't even really need to know that. And then the direction is going to be opposite of P of x, right? Because that's where this is pointing. I mean, I just wrote that on my quiz, that it's going to be opposite of P of x and normal to F of g, since this is F of g up here. So that, again, is going to solve that. Let's go ahead and erase all that and move on. If you need to pause or rewind the YouTube video, please go ahead. For G, write an expression for the magnitude P of the force that you are applying. Well, let's think about this in basic terms and then break it down from there. Let's even erase all of this since this we kind of got. So what I'm going to go ahead and do is say, okay, well I know that P, I don't want to use purple. I just use purple. Let's use yellow. I know that P of x, which is this right here, is going to be equal to f of n uk, right? We just kind of did that because we found out what f of n uk was. So now let's just kind of throw these variables, because we know it's moving at a constant velocity, so we know that the forces in this direction, f of friction, have to equal the forces in this direction, which is p of x. So, well, p of x is going to be p cosine theta, and f of n uk we just solved for, so we know that that's mg minus p sine theta, parentheses, by uk. Well, now it's saying, but we want to find out what P is. We want to find the force that we can that it can actually pull upward, not just this force, but this force too. So now we pretty much just got to solve for P. I mean, this is just basic algebra here. Or we can do P cosine theta equals mg. I'm going to distribute this guy. So mg uk minus P sine theta uk. I'm going to go ahead and do plus P sine over here, so that cancels, and then over here I have P cosine theta plus P sine theta uk equals mg uk. I can take out the p's here. I can get P cosine theta plus sine theta uk equals mg uk. It might be a little big. I don't know how it shows up on the video here, but I mean, obviously, you see what I'm going to do is, in order to solve for P, I just got to divide by this guy, and so your final answer, which let's do over here, is going to be mg uk over cosine theta plus sine theta uk. Sorry if that handwriting's a little sloppy. That is going to be equal to P. So that's what they're looking for, and it's just solving for P, really all you're doing. Now, let's move on to H before I make this video too ungodly long. Now my H, because I know it's different for the quizzes, is assume now that you increase the magnitude of P, so P is getting even bigger now, super arrow or something, so that the force of the fridge accelerates. What is the maximum magnitude of the force P that you can apply and have the fridge stay in contact with the ground? So what it's asking is saying, well, you're pulling up, right? How much can you pull up before this thing starts going up with you? So really it's saying, how much until Py becomes so big that it beats out mg? Now remember, F of n, this force normal is coming from the ground. We're pretending that we're, on some sort of ground or level surface or something. So that really doesn't push you as much as whatever Py doesn't cover, mg, F of n will make up for it. So for, let's just, kind of talk about it. The only force really pulling up on m is Py. This F of n is not pulling it up. It's really a variable force consistent on how much is sitting on the ground. So I can just tell right there, okay, well, when Py equals mg, that's the max that we could get there. At that point, as soon as Py just becomes a little bit bigger than mg, we know that the forces in the y direction are going to be bigger pointing up, so that this is going to start accelerating upward. Your block is literally going to fly off the ground, and then, friction doesn't even matter anymore. So Py, okay, well, let's just substitute that of P sine theta equals mg. So when P is equal to mg over sine theta, that is at the moment when it's going to start moving in upwards. That's like the max it could be at, because that's what they're asking. So, and the justification for this is really just, like, as soon as Py, which is the only force pulling upwards, is bigger than the only force pulling downwards, you're going to have an unbalanced forces, so it's got to accelerate somewhere. It's going to go up, and your box is going to fly up. Yeah, I mean, that pretty much covers it. If you have any other questions, post to the Facebook page. We'll make some more videos to try to make sure everyone understands this stuff. But good luck studying.